Hi guys, a little special video. I hit Craigslist again. I found this. Now it's got, the cabinet's going to need a little bit of TLC, but it's not too bad. There's a few little blemishes and some veneer loss and stuff. Come back out. Now the grill cloth is supposed to be tapestry, but it has dulled and it's got some tears, wear and stuff in it. So as you can see, it's not the best in the world, but it'll do for right now. Now if we look down here on each side, there's veneer loss, but that's pretty well a straight veneer, so it'll be easy enough to fix. There's a couple little blemishes here. What appears to be almost like they tried sanding it a little bit, so, but there is actual loss in veneer. On the two sides they're pretty decent, but at the bottom we do have some loss down there. I don't know if lighting is going to be good enough to really show them, but as you can see, there's some loss down there. And the other side is just pretty much the same. Top's not in too bad a shape. You know, a few little minor little scratches, which is not all that bad. But the nice thing about it, it's all intact. There is a little bit of separation. You probably can't see it, but right along here she's just a little bit loose. This is not a problem. Be tightened up. Same way on the back, there's a little spot. Down here at the bottom, and I'm sorry about the lights, but there's supposed to be a piece that goes across here from this side over. You can see where it would have went. It is gone, so but I imagine it was pretty much just a straight piece of board, so that's not going to be that hard to fix. It just gives strength to the bottom. Otherwise the internals are pretty solid. It's got the speaker in it. Couple of things with it. The output transformer, it's got an open side on one side of the primary. It's got a push-pull tube arrangement, but it's Class A push-pull, which means that if you lose one side, you still have full signal going through, just much weaker. But the cone's in good shape. It's a canvas style cone as opposed to paper. The plug here had been messed with. There's another piece that goes on top of it. I'll show it to you, but they pried it off and the wires are pretty frayed, so they're going to have to be dealt with. But what is it? Well, this is a Philco 95 Lowboy, 1929. And I want to clarify something. I've seen different listings or different people talking about these radios. Low boy, high boy. The primary difference between a low boy and a high boy in the Philco lineup of cabinets is the legs. Low boys have short legs. The high boys have about twice the length in leg length, or a little more. So the legs are a lot longer. The radio sets up higher. That's really the primary difference. Now, I got the chassis out mainly because it was just easier to take it out to load the radio, and I've got her sitting right here. So this is the chassis. It's a TRF radio, 4-stage. In other words, there's 4 RF tunings, 4 RF coils, and 4 gang on the tuning condenser. The dial cord is broke, so the tuning doesn't work. It's going to have a new light bulb here. Obviously it's kind of a little bit loose. Chassis does have some rust on it, so that's going to have to be cleaned up. And I checked all the tubes in it. The output tubes are 45s. They're a little bit on the weak side, but I've got a spare set. Otherwise, the 80 rectifier is actually a little weak, and that's not a problem. I got another one of those, easy enough. But other than cleaning it up and a little bit of rust to deal with, taking care of this dial cord and a few things like that, she's not in too bad a shape. Now, this thing's kind of heavy, so I'm going to set the camera down and rotate it around so you can see the back side of it. Now here's the back. The shield, it's got the decal still on it in good shape with the model number. And not much else to tell. The antenna hookups are here. You got your local and distance and ground hookups. The speaker plugs into here. And I will flip the radio up. Let me set the camera down so you can. I pulled the bottom off. It has a bottom and went on it, which I always like radios like that, because these older radios, when they got bottoms on them, it keeps the insides quite pristine. So it appears to be, other than the power cord was replaced on it, the rest of it does seem to be pretty well all original. And hopefully I can keep most of the original parts in it. Any of these are capacitors, and of course in these two cans are capacitors, and then down on top there is a filter block here, which is right here. It's a capacitor block. I believe there's like 8 capacitors in it. And if, well, suffice it to say, these could come apart with some heat. They're a cardboard tube. They've kind of got that potting material like Philco used on their Bakelite capacitors, kind of a tar wax type stuff. If any of them don't check or are leaky and don't check correctly, I will heat them up and get that out, and then put in the replacement cap, and then of course close them up with either hot glue and paint it, or black hot glue or something of that nature. But I have been doing some spot checks of the dog bones that's in here. I haven't checked all of them, but some spot checks, and the ones that I have checked is matching what is saying on the schematic, so that's good. Now this one, this one, this one, and this one are special. They're a capacitor, but they also have a resistor internally inside of them. Those are the only 4 that'll be, well, you can't check them for leakage because they got a capacitor or a resistor in parallel. So I'll have to figure out what I'm going to do. I may just actually run the radio with them untouched and see how well it works. The big power resistor here checks good. There's another one here, checks good. So now there's something to be said about this particular radio, and I'm going to go over it. TRF radio, tune radio frequency. It uses 24A tubes, which are screen grid tubes, and with the onset, with the introduction of the screen grid, Philco could move away from what they call the Nucleodyne series. When they was using triode tubes to get the best reception and to get the radio to work the best, they had to use a means of using trimmer caps to make certain adjustments in the RF sections to fine tune them. They called it neutralization. It kept, what it basically did was they were running the tubes at maximum gain, and it kept them from going in self-oscillation, is what really was the primary purpose of that. That way they could keep the greatest gain, so the greatest sensitivity to the radio. But with the screen grids coming out, which this one uses, that got rid of that. Now a little history on Philco. Philco started out as being a battery company, and then they went in and started making other components for radios. They can be arguably said to be the first company to actually truly invent and introduce the first wet electrolytic capacitor based on their experiences with wet batteries. And it wasn't long after that that they actually decided that it would be advantageous for them to move into making radios. But they really had no radio engineers on staff, so they hired and contracted out to an engineering firm, Hazeltine, and they made their radios at least up through, or did a lot of the designs, at least up through the mid-30s or at least early 30s anyway. I'm not exactly sure on when Philco basically started hiring their own engineers and moving everything in-house. But this radio is a Hazeltine design. They did excellent work and excellent design work. They also designed for several other radio companies, including FADA and a few others. But this radio in particular is of importance because it's the first TRF radio to have automatic volume control. It has an AVC circuit in it. And it's remarkable because normally an AVC circuit works by use of what is called variable mu, or remote cutoff is what you will see them mostly in the tube manuals, tubes. And these tubes, the 24As, are sharp cutoff. They're not variable mu. So to get a AVC to work with them is quite remarkable, but it did work, and worked very well. And the way they did it, and it's attributed to a man named Wheeler who worked for Hazeltine. He invented this. But the way it's done, get a schematic out here. First I'll show you just the standard schematic here. Okay, this is schematic of the radio. And you got 324s operating the amplification for the TRF. So these are the tuned radio frequency amplifiers. Then you have a detector amp, first audio amp, which then feeds interstage transformer, which gives our phase change so that we can have push-pull 45s, and then of course then that feeds out to the output transformer and to the speaker. If you look at something real close on this radio, on this 27 tube, the grid is connected to the plate. Now most TRF radios of the time used grid leak detectors, meaning basically what they did was they biased the grid using grid leak self-biasing, which is a resistor and a capacitor, but they biased the tube such that when the signal came through, the negative going signal, when it went negative, the tube went and cut off. When it went positive, it would conduct, and then that's how you got your detection. But Wheeler went different with this. He actually connected the plate to the grid, which basically turns this into a diode. Now, I drew out something here just to show the circuitry on our schematic. We have this thing attached as a diode, so now we have a diode detector, but we can also use that for developing our AVC. And one route is it follows down through here, through some resistors, down this way, up to this tube, grid, and through to the first tube, grid, so that as the signal varies, this voltage will vary on these, and the grid voltages will vary. So if you get a strong signal, you get more negative, the tube doesn't conduct as much. Weaker signal, less negative, tube conducts more, so you have AVC. Here in yellow is the capacitors that you normally find in an AVC circuit, and the time constants between the resistor and these capacitances is what sets up the AVC filter. For the last tube, they fed down through this way and came this way and up to the grid. And one other note is the cathode. Being that they did not use a load resistor, they needed to have an established negative. Okay, just hold on a second. The phone's ringing. I'm back. Anyway, as I was saying, we need to have some sort of base negative to work with. Well, this goes to point E right here, this through this resistor, and hooks back up into this circuitry. E is right here, and this is a resistor divider circuit that is pulled off the center tap of the transformer, which means you get negative voltages on these at these two taps here. F is feeding bias voltage for the 45s. E is supplying voltage up here for this AVC circuit as a base voltage. It's about, I believe, around negative 1.25 volts, and then the AVC will follow above this as it operates. But it is a rather remarkable circuit, and it works very well, and does vary the voltage from a weak signal to a strong signal by about 2 to 3 volts, which will be negative, and which is not too bad considering for an old type style AVC. Now, this basic design of AVC using a diode and stuff was actually is what you see throughout radios more modern radios. So I thought I'd point that out, and that's what makes this thing seem to be a little more complicated, or at least more components in it than what you normally find in a lot of TRF radios. So it's going to be fun to work on this one. This one we're going to do little things a little bit different when I do get to it. I'm not just going to blatantly go in here and start replacing capacitors. I will check the ones I can check real easy. Again, there's 4 in here that are in parallel with resistors. It's built right into the package. Those I cannot. There's no means of separation. The wiring is done internally inside here. But the rest of them, I can remove one end from the circuit and do leakage test on them and capacitance test. A lot of guys has had really good luck with these block filter caps and these big blocks. Now, I'm not saying you won't run into some that will need to be replaced, but a lot of guys has been able to, they've checked them and found them not leaky in a lot of these old TRF radios. These are potted in that kind of tar wax stuff, and the main reason why the paper caps generally go bad is because they start opening up, allowing moisture and humidity to get in, which in turn starts them to start shorting out, creating the leakage. This potting material is good enough generally, as long as it's not really badly cracked deep inside. If it's fully intact, it can very well keep moisture out all these years and work. So I'm going to test them before I actually go and get carried away with the replacement. The resistors, as long as they're within every bit of plus or minus 20%, a lot of these actually had a tolerance as high as 40%. So if they're close, we'll keep them in circuit, and unless it deems necessary with the radio in operation that it really does need that resistor replaced. And if that's the case, then I'll try trying to mold them so that I can keep the look. The whole idea of this is to try to keep the look as best as possible. So anyway, that's a future project. Probably after the Admiral, maybe, or I've got a few other things to kind of finish up on. Oh, that plug. Here's the other side of the speaker plug. You notice it's riveted. Well, they had evidently probably had some problems with it, or something with the radio. They had pried this. Instead of drilling the rivets out, they literally pried it apart. So it's caused some cracks in it. And the interesting thing is how they realized, after either discovering what they discovered or not discovering anything or not finding anything or whatever, that they needed to put this back on, because otherwise those solder joints are exposed, and of course you got some of the B plus going on 2 of them because of the dynamic speaker of the field coil. So being they destroyed the rivets, and obviously didn't have any other way of, they felt necessary to put it back together, they used an extremely sophisticated, highly technical means of mounting this back on. And it was really high technology that they used. A material a type of material that heavily engineered. A lot of engineers put their entire life careers into, and It's what they use to hold this back on. And what is that material? Twine. They literally just tied back through the holes with twine to put this back together, which was rather interesting, seeing this twine crisscrossing across there and tying it together. So I cut it loose and pulled it out. I'll have to finish getting rid of the rivets, and I don't have any pop rivets I think is that long. This one's entirely missing, so I'll have to come up. I've got probably something for a spacer I can use, and when I go, get it all fixed up, then I'll either use screws or get some pop rivets that long or something and put her back together. At least a lot better than and prettier than using good old-fashioned twine. So let's see, not much more I can think to talk about on this. I will probably dismantle the top side quite a bit, as much as I can, to clean up that rust. And most likely there's quite a few areas that are rusted, so I'll probably go ahead and paint the top side of the chassis, and with some, I think I actually got some dark gray. It's very similar. The underside of this is actually also painted. There's some spots here. It's got some scratches, but you can see through it. And so I'll probably, I'll definitely paint the top side, and as close to proximity to that color paint as possible. And of course clean up the transformers and choke and stuff, and if they need painted, paint them so that they look nice. The aluminum can shields, these are pressed in place here, but they're aluminum and they're pretty easy to clean once you get everything out of the way, and polish them up real nice so they're nice and shiny. So anyway, I just thought I'd show you this little radio and let you know what I've got. I paid a whole $50 for it, which seems to be lately what I find on Craigslist around here. Must be the popular price right now. But a Philco Model 95 TRF with AVC control. Thanks for watching, guys. See you in the next video.